Welcome to the world of parallelograms. So the first question is, what is a parallelogram? It's a four-sided figure. So let me just draw a four-sided figure first. 1, 2, 3, and 4. This is a polygon with 4 sides and it is called a quadrilateral. Another reminder, the sum of the 4 angles of a quadrilateral is 360 degrees. Over here we have a quadrilateral in which opposite sides are parallel. You will notice that we have double arrows here and we have single arrows here, and that just tells you which side is parallel to this. So by definition, if you have both pairs of opposite sides of a quadrilateral parallel to each other, then that is a parallelogram. At this point, let's go ahead and review some of our properties of parallel lines. So here we go. Now note, these lines are not parallel until I put my parallel sign. Let's include a transversal here. And I'm going to just mark some of the angles congruent, not all of them. Angle 1 and 2 are corresponding angles, they are congruent. Angle 2 and angle 3 are alternate interior angles, they are congruent. Angle 1 and angle 3 are congruent because they are vertical angles. Also a reminder, angle 2 and angle 4 are consecutive or same side interior and they are supplementary. Angle 1 and 5 alternate exterior angles are congruent. Okay, you may need some of this information. So this is just a review. If you have a quadrilateral and its opposite sides are congruent, I want you to look at these two diagrams. Those are parallel signs that are highlighted, and these are congruency signs. Sometimes we tend to get mixed up between the two, so it's important to keep in mind what each one means. Arrows means they are parallel, and vertical bars on a side means they are congruent. Of course, they have to be marked on both sides. Given that it's a parallelogram, then opposite angles are congruent. Now that makes sense because if it's a parallelogram, we know these sides are parallel. So these two angles are supplementary. These two angles are also supplementary. And therefore, if you recall, there's a theorem that says angles that are supplementary to the same angle are congruent. It's called the congruent supplements theorem. This means angle 1 and angle 2 are congruent. That is what we mean by the opposite angles. Of course, these highlight angles are also opposite angles. So let's do that. Let's rewrite that. So that's 2 and okie dokie. already talked about consecutive angles being supplementary. So let's just make a few amendments here. These are degree measures. And because these two lines are parallel, therefore x and y are supplementary, y and x are supplementary, etc. And these two lines are parallel also. Okay. Also, it's just worth noting that 2x plus 2y will be equal to 360 degrees. We know that the sum of the four angles of any quadrilateral is 360, and this is just a parallelogram, but it is a quadrilateral nonetheless. If a quadrilateral is a parallelogram, then its diagonals bisect each other. And the reason for that is that if you think about it, in triangle QMR and in triangle PMS, if you look at these two triangles, we know that because this is a parallelogram, opposite sides are congruent. Also, we know that QR is parallel to that segment QR is parallel to segment PS. So you've got alternate interior angles are congruent. So triangle QMR is congruent to triangle SMR, and therefore by CPCTS, QM equals SM and PM equals, oh, it should be SMP, shouldn't it? My apologies. So SMP, and this is why it's worthwhile checking. So I'm going to write down my CPCT statements here. QM, segment QM is congruent to SM, and that would be CPCTC. Of course, I didn't say why the triangles would be congruent. That's by angle, side, angle. QM, and what else are we trying to prove? MR and MP. So segment MR is congruent to segment MP, also by CPCTC. So all I'm trying to show you is why the diagonals bisect each other. Alright, in this example, ask yourself what's the relationship between segment GH and segment FK. They're the opposite sides of a parallelogram. What does that say about their lengths? What do you know about X and 72? Are they the opposite sides of a parallelogram, etc.? I think the other problems are very doable. On number 3, it says, what are the coordinates of point T? Remind yourself, if you have two diagonals, what do they do to each other in a parallelogram? I believe that they bisect each other. If they bisect each other, then T is a midpoint. So maybe possibly you could find the coordinates of P, Q, R, S, and then apply the midpoint formula possibly to find the coordinates of T. You can decide which points to use and then do a common sense check whether your answer is correct. Good luck.